Hello everyone. In previous video, we had discussed how the technique of page replacement policy it will takes place. Now let's dive into the first algorithm, how that replacement policy it will be taking in the first in, first out. This is one of the simplest page replacement algorithm. In this algorithm, the operating system keeps track of all pages in the memory in a queue. The oldest page is in the front of the queue. When a page needs to be replaced, page in the front of the queue is selected for the removal. So now here we have taken one of the string format here, and this string format it is required to execute in the sequence. So now all the pages, these pages are required in the sequence that will be arranging here in the page. That here it is arranged in the page. Just here you can notice 1, 2, 3, 4 and all up to that all the strings are arranged in the first row. From second row, we have a frames. Total how many frames we have taken means we have taken the 4 frames. F1, F2, F3 as well as F4. The just I'll remove the content of this. These values I'll be removing here. How this algorithm it will takes. How it will be allocating the pages for execution in the frame. Hard disk to main memory, how it will bring, just we have to notice and we have to find out the number of page faults here. So first one here, it will comes one, no any page it is there in the main memory for the execution. So now it will be taking the page one and it will goes to the next one as well as two. It will be continued with the two pages and then again it will takes one, two as well as three. Then again next here we have a four it is required. Four it is not available in the previous list. That's what again here it will be taking one, two, three and four. Now here it will be taking the four. So now here actually initially the frame it will be empty. In main memory no any page it was there. So it has taken the first page. The first page it will takes in the main memory and execution starts. That execution it will be starting and next it is required 2 that it will brings from the hard disk to main memory and then 3 it is continued with the 3 which it brings from the hard disk to main memory. And then next 4, one more frame it is vacant. There it will brings the page number 4. Now what happened? All the 1, 2, 3, 4 frames are filled with the different pages. The next page requirement, that required page is the 1. So in order to apply 1 here, first we have to check in the previous list already in main memory whether that page it is there or not. Now there is a page 1, isn't it? Already it is there in the list means it is not a page fault. No need to bring any of the page here. Here it is not required to bring any of the page. So there is no page fault at all. Here actually the required pages were not there. That's what from hard disk to main memory it has retrieved. So whenever the required page is not available, that is called as a page fault. Page fault it is yes for all these and for this there is no page fault. Then next again after 1 it is required 2. That 2 we have written here. So that 2 I need to allocate here. Before allocating I have to check whether it is there in the memory. Now 2 also it is there in the memory. So no need to go for the replacement of any of the frame to page here. Then next we have to go, means there is no page fault. We have to go for the next one, 5. So in order to allocate 5, 5 it is not there in the main memory. So there is a page fault for the page number 5. So in order to replace this 5, what it will say, the first in, first out. Means which of the page we have taken first here? 1 it is the first taken page. And like that we are continued with the 2, 3, 4 and all. So first in, first out. Which is taken first, it has to send to the hard disk. First it is required to send to the hard disk here. So now here I'll be taking 5 in the main memory and 1 it will be sending to the hard disk. Then remaining we have a 2, 3 and 4. As it is, it will comes. The next we have to come to the next page. Next required page it is the 1. 1 it is not there in the main memory. Just now it is sent to the hard disk. So now again here what we have to do, first in, first out. Means among all these, Recently we have taken 5, leave this one. Among all these, which is the first arrived? 2 is the first arrived here. So first I'll write in place of 2, 1, because I'm sending 2 to the hard disk, as well as 1 it will be taken here in this frame. And then next here we have a 3 as it is, 3 as well as 4. And first one it is the 5 here. Then next we have to come to the next page, that is the 2. In order to take 2, first we have to check whether it is available in the main memory. 2 is not available in the main memory. Then next we have to send, which it has taken earlier. That is first, which one it is taken. 1 it is taken just now, and before that 5 it is taken. And then 3 it is taken. After that 3, here we have a 4. So which one it is required to send means we have to send 3. Then here we have a 4, and then 5, and here we have a 1. Then next we have a 3. 3 also it is not there in the memory. There is no 3. Then we have to send the first which came here, that we have to send to the hard disk. Then 4 is among all these, the 4 which it had come earlier. So we have to send this 4 and replace that 4 with a 3, and remaining here we have a 2, 1 as well as 5. Then come to the next one. Here we have a 4. I need to take 4 here. 4 it is not there in the main memory. Then which is the earlier page? It had come here. 5, then 1 it had come, then 2, then 3. Which is the first come here? 5 is the first come. So we have to replace that 5 with the 4. And remaining I'll be taking 1, 2 as well as 3. Then next we have to come to the 5. So last here we have a 5 which is not there in the main memory. So which it had come first, we have to replace here. That first come is one among all these. So here I have to take 5, and this is 4, and here it is 2, and this is 3. So now the entire process, it has taken in the sequence for the execution. We have to check the number of page faults here. How many number of page faults it is taken means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 12 pages in the string. Among 12 pages, in 10 pages are having the page faults. Only 2 are not having the page faults. That's what here we have a Y means page fault. Missing page it will be showing. And N means it is no page fault. That is a hit. Available means we can say hit here. Which is not available, that is a miss. MISS, miss it is. And number of page faults equals to 10. This is how we can go for the replacement of the pages in the first in, first out. So in first in, first out, we are seeing the previous pages which it had come early that we have to replace. So we are focusing on the past available pages. I hope it is clear to you. And next algorithm in the next video we can continue. Till then, see you.